Hi everybody. Here we go with our last video for chapter 9. And this one's going to kind of combine everything here. So it technically is about section 9.5, which is more of the quadratic formula. But really what we're doing here is we're trying to figure out what's the best method to solve an equation we're given. And over this whole chapter, we've learned 4 main ways to solve quadratic equations. Okay, quadratic, remember, means it's got an x squared. It's degree 2. Okay, we can factor. We've graphed them mostly on a calculator or by looking at the x-intercepts on a graph. We've used square roots, and we've recently learned the quadratic formula. So, how do you decide which method to use? Well, one of the key ideas is we're going to look to see if there is an x term or not. Okay, meaning like we've seen this standard form, the ax squared plus bx plus c equals 0. If that bx term is missing, there's just x squared and a constant, okay, that means there's no x term. That's the best time to use square roots, okay? So an example that could be something like 5x squared minus 30 equals 70. All right, that equation doesn't have an x term, so we could solve it with square roots. Similarly, if you see a parentheses squared, usually a binomial squared, that's another time to use square roots. So an example of that would be 3 times x plus 4 squared minus 11 equals 5. Okay, an equation like that. Anything like that, you can use square roots. If not, if it's got the x term, it's got the whole ax squared plus bx plus c equals 0, then we really have two options. We could use the quadratic formula or factoring, or if you've got your calculator, you could graph it. So an example might be x squared minus 6x plus 7 equals 0. All right, we could solve that by using the quadratic formula or possibly by factoring. So on this video, we've got, I think, 5 examples here, and I'm going to go through them pretty quickly because none of them are examples we haven't done before. But what I might recommend is that before each example, you pause it and try it on your own, and then see how it goes, play the video, and compare. So I'm going to start here. Example 1, we've got x squared plus 3x minus 18 equals 0. Right away, you should notice it does have an x term. So I'm thinking factoring or quadratic formula. So one thing we can do here is we can go right to our discriminant. A equals 1, b equals 3, c equals negative 18. And remember, the discriminant is b squared minus 4ac. Can help us either do the quadratic formula, or it'll also let me know if this can be factored. So when I do b squared, I get 9 minus 4 times a times c is negative 18. So I'm going to get 9 plus 4 times 18 is 72. And 9 plus 72 is 81. Well, because that's a perfect square, I know that this will factor. So I could right away try to figure out how to factor this. So I'm going to go, instead of doing quadratic formula, I'm just going to factor it. We'll go x and x, and we get 18 would be 1 and 18, 2 and 9, 6 and 3. 6 and 3 sounds pretty good. I could do plus 6 and minus 3, and that should get me negative 18 when I multiply, and 6x minus 3x would give me positive 3x. So then I get my two answers. I go x plus 6 equals 0, so x equals negative 6, and x minus 3 equals 0, so x equals 3. And here we go. Moving on, example 2 here, 3x squared plus 4x equals 3. So here, I'm first going to get it equals 0. 3x squared plus 4x minus 3 equals 0. And once again, there is an x term, so I'm going to go with discriminant first. A equals, b equals, and c equals. So my discriminant, b squared minus 4ac, would equal 16 minus 4 times ac would be negative 9. So this would be 16 plus 36 which is 52. 16 or 46, 52. Yeah. That's not a perfect square, so this will have two solutions, but I can't factor it, so I'm going to have to use quadratic formula. So I'll go with my x equals negative b, so negative 4, plus or minus the square root of discriminant, square root of b squared minus 4ac, 52, all over 2a. 2a would be 2 times 3, which is 6. And then let's work on simplifying this. I get negative 4 plus or minus square root of 52 would be 4 times 13. And so I get 2 root 13 divided by 6. And all three of the coefficients here can be divided by 2. So I'm going to get a final answer of negative 2 plus or minus root 13 divided by 3. And that's my solution. Those are my two answers for this equation. Moving on. Example 3 here. What jumps out at me right away is there's no x term. 3x squared minus 7 equals 32. There's no x term, so I can solve it with square roots. So when I solve it with square roots, I want to get the x squared or the squared piece alone. So I'm going to go with add 7 to both sides. I get 3x squared equals 39. And then I have to divide by 3. Remember, you got to divide first. So I get x squared equals 13. And now I can take the square root of both sides. And I get x equals plus or minus root 13. That doesn't simplify, so there's my answer. Okay, notice if there's no x term, I don't have to do the discriminant. I can just go ahead and solve it with square roots. For example 4, I have another situation that I recognize. I have a binomial squared. I can solve this with square roots. So just like or very similar to the last problem, I want to get the squared piece alone. So in order to do that, I'm going to start by subtracting 30 from both sides. You have to subtract before you divide or multiply. So I get negative 1/2 x minus 1 squared equals, that's negative 18. Okay, now we haven't really done one like this in a while, but in order to get rid of the fraction 1/2, I have to multiply by 2 on both sides. And in order, I want to get it positive. So this is negative 1/2, so I'll multiply by negative 2 on both sides. And that's going to cancel out not only the negatives, but the 2. And leave me with x minus 1 squared equals positive 36. Now I can square root both sides, which gives me x minus 1 equals plus or minus 6. Here's where I can split it up to get my two answers. We get x minus 1 equals 6, and x minus 1 equals negative 6, which leads me to my answers x equals 7 or x equals negative 5. And there we go. Finally, example 5. Example 5 looks a little different. 3x cubed minus 12x equals 0. We have to jump back a while, back to the beginning of this chapter. This has a GCF. Okay, it's a factoring problem where there's a greatest common factor. That's something to look for when there's only two terms, is a GCF. Okay, it's got an x term, so I know I can't use square roots. So the GCF I factor out is 3x, and I'm left with x squared minus 4 equals 0. Now, this is a really special problem because x squared minus 4 is a difference of squares. So 3x times x plus 2 times x minus 2 equals 0. Hopefully you're getting good at recognizing that difference of squares pattern. Leads me to the answers. X equals 0, x equals negative 2, and x equals positive 2. Okay, so like I said, this section, or this kind of end of unit, is all about identifying what's the best way to solve problems. So on this slide here. Can you solve with square roots? So we get two equations, so I want you to think about which one you can and which one you cannot solve with square roots. And so if you said for A, yes, you can solve it with square roots because there's no x term, you would be correct. For B, there is an x term, so no, you cannot solve it with square roots. Let's try another set. So in problem A, 6 times the quantity x plus 1 squared minus 18 equals 36. Could we solve that with square roots? We can, because it's a binomial squared. B, whoa, lots going on in B. We have some simplifying to do. So let's combine our like terms here and get them on one side. So I've got a 2x squared I could subtract to both sides. I've got a plus 2x that I could subtract to both sides. And let's finish it off by adding 11 to both sides. Okay, so let's see what we did here. That's going to cancel, that's going to cancel, that's going to cancel. So I know I'm going to still get equals 0. Here I get negative 7x squared. That cancels. Plus 8 equals 0. So guess what? I have no x term in this problem. So here's another one where the answer is yes. I could solve it with square roots. Alright, so that's all for this last video of chapter 9. And thank you for watching.